Alright, time for another draftphysics.com video presentation. So, contest video. Yay! So, a guy called Kurt Jamal, Theories of Everything With, as his kind of channel, it's done lots of interviews with people about stuff that I don't really consider theories of everything. I mean, UFO stuff, consciousness stuff, stuff not really related to physics or theories of anything or everything. And so I'm going to basically call my video a unification video because that's really the physics subject. Now, I did have some past contact with Kurt, and it wasn't very productive or useful. I mean, I did offer him, whatever the price is to be interviewed because I believe I have a theory of everything that's, really a theory of everything, not a fake one or a half one or a 1/1,000,000th of a one. It really actually works. And I've been doing this a long time, and it's pretty well tested in terms of I'm not getting any brilliant counter arguments from anybody. No, the debunkers are failing pretty grotesquely. Even though I have offered channels thousands of dollars to debunk me, and they won't take my money. He wouldn't take my money either. So I'm just saying, just to be clear, I'm grateful that he's doing the contest. It's nice that Brilliant is throwing in some money. I couldn't care less about the money, frankly. I'm looking for attention. I'm looking for people to make counter arguments, defeating my arguments. That's what I'm after. I'm after being debunked. The thing I want to pay people to do, I want them to do it for free. Okay, that's what I want. But anyway, I'm glad there is a contest. I'm glad there's something that might get a few more eyeballs onto the subject. And so I appreciate all that part. I don't really appreciate people not taking my money to debunk me or to interview me. I mean, I don't see how somebody could possibly lose by having me, interviewing me. They'll either make me look like a nut, which is fine. They can just laugh it off and say, well, that was kind of funny. Or they'll end up being some kind of serious conversation. And frankly, I'm pretty good at conversation. I'm not a totally uninteresting character. So even if I was talking complete bullshit, I think I can do it rather entertainingly. And I should at least be given that opportunity. And the fact that I can't get a single flat earth debunker or any other science debunker to pay any attention whatsoever kind of just reveals that they really don't want to look stupid, and I might make them look stupid, and that's what they're really running from. But anyway, enough of that. So I will say that his toe channel is really devoted to a bunch of really abstract physics. He doesn't pay much attention to the foundational stuff, and blah 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 blah. But again, appreciate the opportunity, and so on with the show, where I'll introduce you to a 2 plus 2 plus 2 physics that basically explains gravity and magnetism, electricity and energy and photons and all of that stuff. Now, I didn't do a complete dissection of magnetism and electricity in this video because it was already well over an hour. But there is a hint of how they function in the other subjects, and certainly on the website I have plenty of other videos on those particular subjects, and I will make more videos on those subjects based on anyone who wishes to raise any counter arguments or present any counter evidence. Evidence is really good, so if you have some experimental evidence that proves anything I'm saying to be non-compatible, I'd be interested. Alright, with that said, here will be the video. Okay. Sorry about the long intro, but yeah, it's the price you pay. It's, reality is, it has a context. You really have to include all the context sometimes, or it's just really not the right story. The real story has details. Sorry, but that's the way it works. Alright, starting at the beginning. It's a mechanical universe. I probably should say that. It's all just physics, physical stuff interacting, and consistent with that idea, it's a push universe because push is really simple. You throw something at something else, it hits it, it pushes it, and I mean push, not just hit, bang in is a little different than push. So there are subtle differences, and those will be explained. But it's a mechanical universe. There is no, I pulled it towards me with my magic pulling forces. There are no magic forces. Some force, some real thing has to interact with some other real thing. And the fact is the elemental universe is elemental. It's simple. It's got very few kinds of things. It doesn't have complexity. It just has a density. It has a lot of stuff, but it's really simple stuff. Richard Feynman used the analogy of a infinitely large checkerboard. Really simple rules, but if you make the board big enough, you can make all kinds of complex shapes. Obviously, it's like pixels on your computer screen or whatever, your phone. The more pixels, the more complex the image you could produce. And that's what the universe is doing. It's just using a lot of stuff as the fodder for creating places where very unique and rare and not very often things happen. So what looks like a universe that must be made out of something complex is really made out of very simple ingredients. I suppose you could make a cooking analogy. You can use really simple ingredients, flour, sugar, water, blah, blah, blah. And you can make all kinds of different things out of those ingredients. And that's all the universe has done. It starts with just 100 basic atomic structures. So you can understand that, yes, you get a lot of chemistry out of just 100 elemental bits. And the same is true for the even deeper step before atoms, is that the mechanics are very simple. So I'm going to be arguing for 2 plus 2 plus 2 physics. Physics that just says there's only two kinds of force, two kinds of matter, and two kinds of interaction, and all of that explains anything that happens in the universe can be understood in that context. So, moving on. Alright, 2 plus 2 plus 2 physics, the replacement for bent space, entanglement, wave-particle duality, relativity, all the conventional ideas, kinetic energy, all of it is unnecessary. It's this simple description of the elemental functions answers all the questions. More specifically, it answers things that the physics can't explain at all, like the forces of magnetism, electricity, photons, all the electromagnetic and charge effects are more precisely made rational through this process. And yes, the accidental byproducts are perfect explanations of gravity and energy. So that's all you really need to start with, is this simple basic functions that I will detail. And so we'll wait to do that. Well, while I still have this graphic on the screen, the 2 is 2 kinds of force, 2 kinds of matter, and 2 kinds of interaction. And that's all you need to explain the mechanics of everything you see around you, and how it functions, and how it moves, and why it moves, and all of it. All the chemistry, all of it can be explained by just understanding the simple idea that stuff is being pushed around in the universe by these really simple 6 rules. And that's it. It's all you need. Alright. Alright, so force. We'll do force first, but matter's just as integral. You can't really have a force without the matter, so I could do matter first, but force is the more elemental, the smaller bit. And it is a bit. It's all particle physics. All the physics is particles, things, objects, hitting objects, pushing objects. That's the momentum, that's the energy, that's the action. That's what makes the universe possible. And the force, you could all understand, I could say to you, there's the speed of force. Now, we call it the speed of light, but it's technically the speed of force because the other forces are happening. They make events happen at that same speed. Physics basically concedes that gravity moves at the same speed as light, which is a huge giveaway, that it's all about just one kind of force that just has two shapes. So the idea is that there's an electron force and a proton force. That's it. They're identical. It's just that they do opposite things when they encounter an electron or a proton, which makes it possible for you to create attraction and repulsion, which is the whole reason there is charge, and then electrodynamics is all based on essentially this phenomenon. Magnets, it's all made out of the fact that you're controlling, you're manipulating this function of the same force acting on electrons and protons completely inversely. One force pushes the proton, the other force attracts the same force attracts the electron. And the attraction is in the form of a negative push, the absence of a push. And it's really going to come down to something that simple. But the fact that all the forces move at the same speed is a huge giveaway that it's all the same stuff. They're bits of force. They can be quantized. They can be understood as little pieces of momentum. So the universe is literally what this background shows. It's purple, and the purple is made out of red and blue, you could say. Electron force and proton force. And all that happens in the universe is that force interacts with matter and it comes out separated, blue and red. And that is what makes everything else possible. So just two kinds of force. They're little tiny bits moving the speed of light. They have momentum. So that means they have some sort of mass. They're real things in the universe. They're tiny, quantized little bits of momentum. And they give matter momentum by sticking to it, by pushing it, by interacting with the matter. And it really is just that simple. And we'll see if there's anything else I have to add, but I think that's sufficient. Alright, two kinds of matter. That's all there are. So in spite of what physics says, that there's 400 different kinds of little particles, little things flying around inside of atoms, the only part that's really been demonstrated to exist are electrons, protons, and neutrons. But neutrons have been found to be made up of a proton and an electron. So they're made out of these elemental matter bits, the ones that carry charge. So it's really just, that's all there is. There's just two kinds of matter, positive and negative. Electron particle and a proton particle, and those two particles behave inversely as stated. I would argue that the structure of atoms is a consequence of the fact that the protons happen to be heavier, and that is they're harder to move, and that's why they end up in the nucleus of atoms and the electrons end up on the outside. It's because the protons just aren't capable of being moved around by the same amount of force, where the electrons can be. Now the two kinds of matter make the two kinds of force meaningful, so because they interact, and that's the key point. So that's when we're going to start doing some drawing. But that's all there is. There's the fundamental, there's really no place for gluons and all this stuff they claim exists, all these taus and all these different particles. They can't put them inside of an atom and then draw you a picture of how the atom works. There's no room for antimatter. I mean, where is all the antimatter hiding? There's no room for anti-electrons and anti-protons and all of this partner universe. They can't draw a picture of it because there's no place for it. It ruins chemistry, it ruins everything else. Nothing else would function without the simple understanding that it's really just about the charges and their interaction. I suppose it should be mentioned. I can always, could do it later, but that the whole diagram of an atom with electrons spinning, rotating, orbiting, is, in my opinion, wrong, and that the real model of the atom is magnetic. That if you think of the electron and proton as magnetic monopoles, you can understand why they would create tension between each other and create a structure that would be solid and consistent. So when electrons are shared by atoms, they're literally shared. They're not traveling a figure eight or doing any of that stuff. They're in a location in space, and they might be jiggling a bit, but they're shared by the two nucleuses, the protons. And that model, I think, works much better. And but I'll provide more explanation as we move forward. Alright, two kinds of interaction. This is the big idea, the thing that makes the universe work, and more specifically, it describes a complex function with the simplest of explanations. So you have this phenomenon where electrons and protons interact in specific ways. So if I have another electron here, another proton here, that will probably help explain it. So we know that these two repel each other, okay, and that these two repel each other, but somehow these two, okay, the opposites attract, okay, and I don't know how to draw that, so we'll just do this with it. But anyway, and the reason that happens is because, as I described, there's this force in the universe surrounding everything. And the force is essentially, if this was blue and red instead of red and green, okay, you can understand that this looks purple. It's just a mixture of the two colors. So brown in this case. If you mix red and green, you get brown. And that's what's coming. That's what's all in the universe. It's all traveling in all kinds of different directions. The force is all over the universe. You know some of it because some of it is created by you. Your cell phone, microwave oven, all kinds of objects are constantly creating this force. These little bits of radiation, these radiating bits of momentum that are flying around us all the time, and we're constantly being pushed from all directions by this stuff. And the fact is these two things will filter that stuff. So if I have a red force goes into an electron, so the proton force hits an electron, what happens to it is it turns into a electron force. It just goes through the object and is converted into an electron force. Now, if an electron force hits an electron, it now will give the electron momentum. That means it'll push it until an opposite force hits from the opposite direction, and they both end up reflecting. So an object will keep moving as long as it's had extra bits hit it from one side, extra electron force in this case. So if 3 more pieces of electron force hits the electron from this side, then this side, for a given period of time, then this will have a bias of 3 electron bits in this direction, and it won't be until a compensating force hits from the opposite side that those will end up being reflected until it's back to going no velocity again. So it's just about a balance. Any imbalance in the field energy will cause the matter to reflect that imbalance reflected in its motion, in the sense that it'll capture that energy for the period of time the energy is pushing the electron. But the consequence is that you can understand that if the only thing the electron force can do is stick or reflect, then the electron will sit in space, just as Maxwell's drawings demonstrated, as just a radiating body. It's just radiating electron force. Anything red that goes in comes out green. Anything green that goes out comes out green. So the electron is just a little radiator. Now, it's not radiating any of its own energy, just like you substantially are not radiating your own energy. You're reflecting the light. The light has to hit you for you to be visible in the dark. Now, you are radiating some heat from your metabolism and other things, so there is some radiation you're emitting, but you can understand that most of the radiation you're emitting is just energy reflected. You don't absorb the energy and keep it for very long. You're an equilibrium. So if I hit you with some sort of energy, The fact is you'll likely radiate it within a few seconds. So if I hit you with a microwave burst or something, and I heat you a little bit, you're going to reflect the energy, sometimes very quickly, sometimes with a slight delay, but you're at equilibrium. And so is the electron and the proton. They're at their own equilibrium. And all that's happening to them is they can be hit by more energy from one side than the other and be caused to move. So anyway, in this scenario, you can understand that the electron is only radiating electron energy, and the proton is only radiating this the opposite force. So you can understand if the red force does nothing to the electron except turn into green force, so the red force goes into the electron, comes out green. All right, so it doesn't do anything. It doesn't cause any action. It just causes a change in the force. That the two objects would end up being attracted because all of the force that would affect this proton, that is any red force coming this way, is getting converted into green force that passes right through the proton. So you can understand that it's getting hit by plenty of red force from this side. It's not getting hit by any red force from this side, so it moves towards the electron. So it's not being attracted, it's not creating an attractive force, it's just saying you're taking away a push. This was a push that can't get to the proton, and therefore this push is now extra push. This is now an imbalanced push. There's more push here than there is here, therefore it moves in that direction. Same thing's happening to the electron. So with this simple mechanical mechanism perfectly explains the charge phenomenon, completely consistent with Maxwell's equations, in the sense that all you have to do is, these lines, it will tell you how much force you're going to interact with. They're basically, you can make 1,000,000 lines, you can make 10 lines. You can understand that it's just about how many of these lines you intersect are going to decide how much blocking force there actually is, and how much you're going to end up having a differential that's going to push you towards the electron. So the closer you get, the stronger the force gets. The further away you get, the weaker the force gets, because basically the object's getting smaller. You can understand as the two objects get further and further away from each other, they're essentially getting smaller in the sense that the universe they are now in is much bigger. So this universe out here gets bigger. As this object moves further away, it's exposed to more of this and less blocking. So that's the obvious reason why the force gets weaker. And so with this simple mechanism, just these two rules. The rule is when the opposite force hits, it just changes. And when the same force hits as the bit, it's eventually reflected. But it pushes until it's reflected. It pushes until an equal and opposite force hits from the other side to cause it to be rebalanced again. So if there's, again, if I'm flipping coins on this side and I'm one head ahead on this side, then obviously something has to happen on this other side. They have to create the head to compensate for the imbalance that exists. And when the two sides are equal, then the object loses all its momentum, all of its velocity. So so that's probably a good enough start. So the most important phenomenon in physics is charge. This simple mechanism explains it. Conventional physics really doesn't explain it at all. They just say there's this magical force, this magical creation of something, mechanism, but they don't account for its origin. Its origin is space itself. Space is full of energy. Right now everything in space is radiating it. Okay, it's showing you some of it, but space is full of it. Okay. And that energy is what's causing the compression of every material object. Every atom is being forced into its configuration. Okay, the configuration of the electrons and the protons is happening because the universe is pushing them into each other. Everything's being pressurized by a universe full of these force bits, and the key is that these matter bits can filter it. And so the idea would be is you can create a dipole, that is something that has a red side and an electron and a proton side, and you can understand that the brown comes in Okay, the mixed universe comes in, and what's going to happen is it's not going to be mixed anymore. The one side is going to produce red and the other side is going to produce green force. And so now you have your dipole, you have your polarity, and that is the function that creates magnetism and electricity and all the other phenomenon. So I think that's probably enough to start. And we'll see where we go. Alright, the subject, gravity. It's the first kind of logical symptom of 2 plus 2 physics, in the sense that we have two interactions. If a proton force hits an electron, it just goes through and changes its identity. It becomes an electron force. If an electron force hits an electron, the electron, it sticks, and the electron moves. Now, it moves at a velocity far less than, the speed of light. So the more force that hits from one side, the faster the electron can move, but it incrementally increases, and it doesn't stop moving until a counter force applies the opposite experience, which causes reflections of the force. So the stopping force doesn't cause any motion, it just takes motion away, and that's essentially the energy. So this idea that something, traditional particle models of gravity have an idea of some ultramundane particle hitting, and then it stops moving and it gives this motion. And that diagram, I would argue, yes, that doesn't work. Because we know energy doesn't stop moving. So that's a key point I suppose should have raised earlier, is the force is continuous. You can never destroy its energy. You can only occupy it. And that's the key thing that's recognized here, is that you had a force in the universe that was going the speed of light. And what happens when it hits an electron is that it travels this distance not at the speed of light anymore. It's something less than the speed of light because it's stuck to a piece of heavier matter that it's pushing. So this reduction in its motion in the universe, essentially, if you add up the distance traveled by a piece of energy, the more matter it hits, the less distance it travels, the less its actual velocity. So in a sense, you are taking away its momentum. So the more times it interacts, the less momentum it has in the universe. So in a sense, matter is a sink. It's an energy sink. The more matter a force encounters, the less of a story that piece of force will be able to write, because it won't be active in the universe. It'll be stuck moving very slowly, doing less things. So the obvious circumstance in gravity is that you have this idea of there's somehow more going in than comes out. And you can see that in lots of ways. You can see it in the sense that the pressure gets greater and greater and greater as you go to the core of some gravitational body, indicating that pressure has to be constantly fed, constantly maintained. If you don't maintain it, if you allow something to relax the pressure on the outside, then everything on the inside would expand out. So then you get very high pressures in the center. That's what makes nuclear fusion possible, is the high pressure inside the sun. And so you have an obvious circumstance where it seems what's creating all of this pressure. Now they say bent geodesic, they say bent space. I say clearly the argument is the universe is full of this energy. The energy is constantly hitting the Earth. So that is proton energy and electron energy, but they're doing exactly the same thing. They're just doing it inverse, so they balance out. So unless you have some polarized matter inside the Earth, you're just going to get out what you put in the sense that you're not going to have more electron force or more proton force. Those two will be balanced. So this argument can sort of be drawn without worrying about the distinction. Again, unless you polarize the atoms. If you have a bunch of polarized atoms, then they'll obviously start reflecting more red at one end and more green at the other end, just in terms of what they'll reflect. So this is sort of, it answers the question, what's creating gravity? Well, there's more little bits of energy moving the speed of light going into the Earth it's being occupied moving matter towards the center of the Earth and creating high pressure, and that occupies its energy, a portion of its energy. So yes, of course you get less out. So more goes in than comes out. You're standing somewhere in space or anywhere, and the gravity's already there. The Earth has already created it by absorbing the energy that would have hit you. The universe is free to hit you with all of its energy. Because the Earth is here, the energy coming from this direction has been, a portion of it's been consumed in a sense. It's been stored in the pressure created inside the gravitational body, and therefore it doesn't get to you. So less energy comes out at you this way, and that's gravity. And if obviously the closer you are to the body, the more this affects you. Okay, the stronger this cone, the more lines of force you will intersect, and therefore the gravitational difference, the amount of energy that can't get to you, increases the closer you get to this surface, the more places that you can't see, okay? The more parts of the universe you can't see. So it can be understood as a shadow, but that's a little bit too simplistic. It's a consumption in every direction of the force by the fact that it's being occupied moving matter. Moving matter degrades, okay, the force in terms of where it will be in the future. It's delayed essentially by this process of moving matter, and that delay is enough to create this energy imbalance, which clearly causes every proton and electron, and that's what's being affected by gravity, are the protons and electrons. The atoms aren't being affected. The pieces inside the atoms are. The material bits, the real material bits, are being pushed, and the protons by the proton force, the electrons by the electron force. And they're being pushed to the center of the mass because they're all doing this simple process of effectively shadowing each other, preventing force from reaching each other by blocking it, and therefore any two objects in that field will move together. Now you could prove this with just a simple model of BBs. If I had BBs that could keep moving and I put them in a box so they never stopped, they were little perpetual motion objects, and I put any two objects in here that weren't those, they will be pushed together. They'll eventually move into each other because of this very fact that every impact, there'll be less impacts where they're facing each other and more impacts coming from the rest of the environment, and they'll be moved right into each other. So, there's so many things that make it kind of obvious that it's a real force, gravity. It's not bent space. It's real energy, real momentum. The fact is that some of that momentum of the force is consumed by pushing matter, delayed, stored, and the price of that is the continuous degrade in the amount of energy coming out. Pressurizing the Earth, constantly pushing against it, forcing it to stay pressurized, consumes energy, and that creates gravity. I think that's enough for this first piece, and some more details later and such. Alright, atoms. Okay, the conventional notion of how an atom is structured never, frankly, made any sense to me. The idea that you would have a net positive nucleus and then have an electron that is orbiting like it was gravity or something, and that you would combine another atom, okay, with that object. Whoops. Technical error. Alright. And somehow this little bit, this would be called sharing, going around this way and around this way, and it would be doing this at this incredible speed, and somehow that would be combining two atoms, like somehow they would stay combined, even though the electron at one point is going to be way over here, and there'd be no reason for this proton to stay here, this nucleus. It's in this universe full of stuff happening, your cell phone calls, all kinds of stuff happening to it, and yet they're going to stay in this position while the electron plays this little game, and somehow the net force bonding them would be the same, and it would be a strong enough force to keep everything together. Well, sorry, way too complicated. Why does the electron, where does it get its velocity from? How does it maintain it? Where does it come from? None of those questions answered. So anyway, for me, a magnetic model of the atom always made more sense. So that's sort of how I've, without directly and overtly stating that's how I saw it, that's how I saw it. And that the electrons were in fixed positions, and that this is the right model of how atoms stay together, is the very fact that they have attraction here, okay, but they have repulsion between each other. So you can understand, if I could create this, you know, I can do it under a piece of glass. I can just basically have a south-facing magnet in the center, and then have north-facing magnets placed between the layers of glass. And the fact is, I could create this arrangement. I can create it so there's the repulsive tension between these balances against their attraction to the center. So that, and the idea would be is they can't really move in this direction without moving closer, okay, to the other electrons, meaning their force, the repulsion force, gets stronger. So as they move towards the proton, the repulsive force between the other two electrons is stronger, and it stops them from moving any closer. So you can create this balanced atom where the electrons are in a condition, okay, where they don't need any velocity to keep them in positions. They're not fighting gravity, technically. I mean, quite overtly, they're not fighting gravity. In a sense, they're actually, you know, fighting charge, okay, but it's, like I said, it's a balanced charge. So this also explains inside of atoms, you know, the strong nuclear force is described as a thing. It's some sort of thing that exists inside of atoms that allows you to create a nucleus. And I would argue the simple explanation for how a nucleus is created is you take two very strongly repelling electrons, I mean protons, and they're kind of easy to push together if you just stick an electron in here. If you stick an electron in here, then all the pressure, all the force, the red force, is converted into green force coming from either one of these. So neither one of these can hit each other with their repulsive force, because all the repulsive force gets converted into a benign force that passes right through them. So they don't feel each other's pressure if there's an electron between them. And this arrangement, you can call this a neutron, and you can call that the extra proton. So one proton plus one neutron equals something that can be obviously occupy a very small amount of space, because you can move the two protons very close because you have an electron in between them. And then you could do this, and you could do this. So the nucleus is essentially the opposite of what's happening on the outside of the atom, in the sense that the nucleus is creating an environment for protons to get close together. So, you know, this makes it kind of easy to, you can understand how atoms, and there's only 100 stable ones, you know, whatever, a few isotopes and this and that, but there's only 100 varieties of, or configurations of these electrons. So you can sort of understand that magnetically that would make sense. If I add electrons, I have to add them in equidistant positions because they're all sharing pressure. So they all have to be in an equal, you know, they all have to find a balanced position. They're all attracted to the proton, especially in places like this. You could understand that if you're looking at the atom from any position, from one position it's going to look positive. You're going to be able to see. So like from this position between these two electrons, this is going to look positive. From this location here, it's going to look negative. You know, so depending on where you're looking at the atom, it's going to look different, and that's the nature of the polarization and eventually magnetism and all the electromagnetic radiation and all that stuff. But anyway, this model, you can understand that you're actually sharing the electron. So if you combine two atoms, they're actually sharing an electron that stays in a position in space, and all you're doing is adding another proton for it to be attracted to. All right, and that configuration allows you to combine atoms because you're actually combining them. There's nothing required to swirl between all of them and do all this fancy stuff, because the electron's in a fixed position and you're just adding another magnetic object and just combining these magnetic objects in a sense. Magnetic in the sense of the monopoles are basically the protons and the electrons. And so in my opinion, you can't really understand photons. You can't understand anything if you have all this stuff moving around inside the atom. You really can't explain where the photon is created, how it's created. So it destroys continuity. It's just a bad foundation. If this is wrong, okay, you can just sort of understand. If this is wrong, it's the wrong idea. It's profoundly wrong in the sense that, you know, the whole mechanism has changed, and everything you're going to say about what electromagnetic phenomenon is going to be wrong. So I think that's all that needs to be stated as a preface for the other subjects. Yeah. Okay. Till then. Alright, the subject's photons. A very big subject. Lots of experiments. You know, we see them all the time. And so there's lots of things to talk about in terms of how photons function, what the rules are. And I would argue the conventional idea of some kind of waving cool thing flying through space is just wrong. Photons are the same energy that's in the universe, the same energy that causes gravity, that causes all kinds of other heat, all kinds of other stuff, all kinds of radiation, all kinds of force, the stuff moving the speed of light. It's made out of the stuff moving the speed of light. The bits that make charge, the bits that make magnetism, the bits that make gravity. And it's just a shape of those bits, a way they land on a surface. So photons don't really fly through space to you. They land on you in the sense that you can have a piece of a photon come from one direction, another piece from another direction, another piece from another direction. And it just matters about how they land. And if they're in the right shape, the right configuration in landing on a surface, it's received by atoms as a photon. So any notion that electrons or single atoms produce photons is not correct. They produce force. There's force bits that are flying out of atoms all the time, but they're not complete whole photons. It takes numerous atoms to create a photon, because you need numerous pieces at the right interval. So the traditional notion that there's something called electromagnetic radiation that's doing this, you know, the traditional double helix kind of drawing, you know, and they never tell you how many of these little loop-de-doos you need to make a photon. They don't really talk about any of those facts. This is just wrong. There's no electric field and there's no magnetic field and all of that stuff. So all a photon really is, it's just bits of the momentum. So you have bits of the force, the same bits that do everything else, and they're just at a specific interval in time. And the trick is they're also at a polarization, that is, they're at positions in time that's also the same as the wavelength. Okay, so this distance between them is the same as the distance, or it's at least proportional to the distance through which they're traveling through space. So if I painted three little dots, you know, on my hand, I could simulate a photon by saying it can come this way, it can come that way, but it really isn't doing that, because experiments like the double slit experiment kind of prove that the photon isn't a photon till it lands. It's about how it lands on a surface. So anyway, so obviously a frequency, okay, can be considered a wave, but it's not a wave, okay? It's just a frequency, an interval in time. And this is the same thing, an interval in time between these different places they land. So the argument is that photons are created by electricity because atoms, you know, so now these are atoms, not force bits, they transmit Okay, so they're pushing on each other's electrons. That's electricity. Okay, and as that's happening, this is happening. Okay, a little pressure into the universe, a little pressure into the universe, a little pressure into the universe, a little pressure in the universe. So that's creating the polarization, the intervals. Okay, so you have one bit fly off here, and then you have a bit fly off a little bit later, and then a little bit later. So this one's here, and this one's here. So this is creating your photon. This one moves here, this one moves here, this one starts here. And that's your photon. Okay, your photon is created by numerous atoms. So if you take the wavelength of light, like 500 nanometer light, that equals, okay, almost 1,000 atoms worth of distance. So you can understand that the polarization is quite gigantic of a photon. Can't possibly be created by an atom with an electron and all of a sudden a photon pops out. That's the traditional notion. Well, there's no way one atom is making something that's 1,000 atoms big. Okay, and there's no way that something 1,000 atoms in size lands on a surface and only affects one single little electron. It's obviously doing something to the matter. Now, the simple argument is you just inverse this process as a landing process. So photons land on atoms. I suppose I could just draw it over here. Okay, so there's a row of atoms in a surface, and the photon hits, pushes an electron, and then another photon hits an atom that has the pressure from the first hit. Now it doubles the pressure of the electron, and then another one hits and it increases the electron pressure even more. Another one hits and increases it even more, and then eventually it can ionize it if it increases the energy enough. And that explains the different photoelectric effects of the photo effect of ionizing or shooting an electron off the surface, which only ultraviolet light can do. Because ultraviolet light is essentially, it's like feeding a pendulum. You want to put energy into a pendulum, you have to keep hitting it when the pendulum's swinging in the right direction. So the idea is the more you hit this electron from behind, so the electron's moving this way, you want to hit it from behind, keep pushing it. Well, the ultraviolet light, for most atoms, that'll be the threshold, where you're maximizing how much energy you're getting into the electron and how well it's going to ionize. And if you increase the frequency, you'll increase the speed of the electron, and you'll increase the speed of its ejection. So all of this is consistent with proven experimental data. And the other effect is that if you don't quite get that much energy to shoot the electron out, but you do keep pushing it and pushing it and pushing it, that's called electricity. So clearly you're creating the same effect. The effect that produces it, the antenna effect of shooting electricity through an antenna. So you put electricity into an antenna. What's it doing? Well, it's affecting an atom, then it's affecting an atom, then it's affecting, and it's a timed equation. At the speed of light, or close to it, the electricity goes through the wire, and in doing that, it triggers this atom, then it triggers another atom, it triggers another atom, and it's a timed event. And this is also a timed event. So when you're causing the photoelectric effect, you're just duplicating essentially what caused the energy to be emitted in the first place. You're causing a cascade, which is causing pressure to move through atoms and creating electricity. Right, so that's first stage. Now we'll get to the two-slit stuff, which is just a mess. They made a mess out of a very simple experiment, and so I'll explain. It just sort of proves the point that the wave model is not. The particles explain, waves do not. Alright, before we get to the double slit, it's important to understand the mechanism. So there's electrons in atoms, and the idea is that electricity or some sort of other effect, mechanical effect on atoms, changes their shape essentially. And they're polarized by the fact that you're putting pressure into them. You're pushing one electron, it means you're pushing all the other electrons, and you're essentially changing the shape of the atom. And when the electron moves, it's moving as if it's a body in space, as explained before. It's sitting there in space, empty space, in the real universe of empty space, and it's constantly being hit, okay, by energy, as pointed out, and it's going to be both electron and proton energy, and the energy it's going to reflect is always going to be the electron energy. So photons are made out of electron energy because they move electrons. But every time a photon moves, okay, in its environment, it changes what leaves. So again, all the electrons and protons are doing is producing an effect on the field, on the external world. They're just reflecting the world. So just like I'm reflecting it, this hand is reflecting it. So if I move this hand towards you, if I could move it at the speed of light, what it would do is collect all of the energy coming this way towards it. And it would collect it all because none of it could reflect faster than the hand is moving. So if the hand could move at the speed of light, you could understand that all of the energy in the space between here and here would be condensed into one piece of space, one plane of space, and on arrival you would get hit with all the energy at once. That would be zero frequency. Okay. Anything slower than the speed of light, you can understand, would have a thickness. It would take the thickness of this distance and it would compress it into a smaller space. And the slower I go, the wider that space gets. But any speed is going to compress all of the energy a little bit. So energy coming at me at a certain frequency, 50 hertz, who cares? If I move into it, I'm going to shift it. I'm going to blue shift it. I'm going to condense its frequency. So that's what's happening with electrons creating photons. It's taking the common energy that they're always getting hit by, and when it moves into it, it creates a compression. And the same thing happens when it moves away in reverse. As it moves away, it takes energy that was in this much space and it makes it energy in this much space. It reduces the density of the little bits. It changes their frequency. So every time an electron moves, it's creating what could be called the pieces of a photon, because it's creating places in space that have more of these little force bits than other places. It's creating compressions and expansions in the density of the force, which is the Morse code. Those are the bits that the code is built out of. Alright, so that's probably enough of that, and so now we can get to the two slit. But it's a key thing to understand. This is energy happening. Expansion, contraction. And this is what electrons are doing. So when electrons move in an atom, see, this breaks the whole idea that electrons are already moving, that they're spinning around doing all kinds of stuff, because they would be creating all kinds of changes in the environment if they were. They're in stable positions and they're jittering this way, and that is causing increases in the frequency and the density of the force. And that's why we're radiating infrared radiation, is because our electrons are moving because we're heated and there's force bits moving electrons, and that goes through all of our little bits, and all the electrons move, and the ones on the surface are showing us, okay, are sending the signal to the universe. They can't push on another electron, so what they do is they push on space itself, in the sense they push on the external force coming in and reflect it at a higher frequency. Alright, so the traditional two-slit experiment, they call it the Young double-slit experiment, and it's a big giant fake. Okay, because what they do is they put a condition on it. So when Young drew it, he didn't put any conditions on it, obviously. And it's this idea that two waves go out, create interference, and create a pattern. Okay. Now, the truth is, they say that to do this Young experiment correctly, you have to have either an infinitesimally small impediment, that is a very small wire, smaller than the wavelength of light, or you have very infinitesimally small slits, so smaller than a wavelength of the light. So really, really very, very tiny slits. And what you do when you do that is essentially destroy, if you thought of these surfaces as point sources, obviously if I bring two of these point sources very close together, they're not separate point sources anymore. They become single sources. So if I make the slits infinitesimally small, you can understand I've turned 4 point sources into 2-point sources. And I'm really just going to get the single slit pattern, because all I've really done is turn the double slit into the single slit. And so that's all Young's analysis has in it, is this. Okay, we know the double slit pattern creates a completely different pattern, something like this. Okay, that it has 2 patterns in it. So a well done double slit pattern will show this 2 patterns. This isn't in any of Young's analysis. He doesn't account for any of this stuff. The idea that there's these breaks here and here. So it's really not the double slit pattern. It really doesn't have anything to do with it. And so if you really analyze the double slit pattern, you have to explain why there's 2 patterns here. All right, and if you really do the analysis, which I will redraw, and so I'll be back momentarily. All right, so there's 3 versions of the experiment, right? You could do the single slit experiment with just 2 surfaces in that configuration. You can do the single impediment experiment where you just, put a single pin in front. So Isaac Newton did both of these 2 experiments. He didn't combine the 2, okay, and create a true double slit experiment. Now, these 2 experiments create the same pattern, okay, the same mathematics will apply to both of these. This will be the distance between the surfaces, okay, and they, but they always call it the opening, but, and they'll give that a variable a or whatever. But yeah, obviously they can have the same number, and if you have the same thickness or the same opening size, you'll get the same mathematical configuration for a pattern. But again, it would be a single slit pattern in the sense it will just be bars equally spaced with one central maxima that's twice the size. All right, so that's another thing they don't explain. Okay, they just create a gimmick where when they're doing the math for one experiment, they make this a 0, and when they do it for another experiment, they'll make it a 1 in terms of counting. And with that little trick, they'll be able to compensate for the fact that the pattern has changed. Well, for the double slit, they use a different counting. So for the single slit, they use 0 as the origin, and then for the double slit, they use a 1 to account for the fact that this phenomenon exists. Anyway, so the argument I'm making is that this is a particle phenomenon, and all the surfaces are doing is that everything that happens, all the fringes, so any light that doesn't go here, okay, straight through the opening, let's say, okay, and this is 90% of the light does this in the single slit. All of these pattern light is being created by the surfaces, that is photons that go by the surface and are essentially broken, that is pieces of that, that configuration of the photon. A piece will hit an electron, and by hitting an electron it'll go in some direction. So let's say an electron is in the atom and you hit it. If you hit this electron, it'll go straight. You hit this electron, it'll go this way. Depending on the pressure of the atom and how the electron is configured, the photon's energy, that is the motion it's going to give the electron, will be different depending on the position of the electron. Some electrons can go straight, some electrons can't go straight. So they have to go in a different direction because they can't get closer to other electrons. They have to avert the other electrons, so they have to go in a direction where they are going to minimize their interaction with the other electrons. So every time a photon hits a piece of a photon, that is a piece of energy, hits an electron, it has to do the mathematics of where does the electron want to go because it's not going to necessarily go straight. So in a sense, the electron goes in a direction. When it goes in that direction, it's pushing on the force, that is, it's condensing a piece of force, and so it's sending the energy into the field by compressing the field energy. So it's not the same bit of energy that is being converted. It's a new bit of energy that the photon's going to be converted into by hitting these electrons. But anyway, so that's what happens. It hits electrons and it gets scattered. All right, in all directions. So on the 2 surfaces, you basically have, that's where the waves are. Okay, that's the sources. That's where the source of the fringes is. That's why this variable is so important, because those surfaces are the sources. It's 2-point sources, And you're really just saying, what's the geometry of the scatter? Well, the scatter says there's certain points that will get hit by both of these. And when this is a full wavelength of difference, it means you've restored this phase. You've taken photon pieces. So you have a piece of a photon hits over here and a piece of it flies off. Another piece flies off from this one. Those pieces are at the right phase now because it's a full wavelength of distance. When it's not a full wavelength of distance, the photon would look like this. That's the wrong frequency. So when that hits the surface of atoms, it's not going to push the pendulum at the right resonant frequency. The atom has a pendulum swinging. The atomic structure of the material is like a pendulum. The electrons have to be hit in a certain time to be able to add energy. If you hit the wrong time, the electron's moving the wrong way. It's moving back to the atom. You're compressing an atom, squishing it, pushing an electron out, and the electron's going to go back again. The atom's going to unsquish. You have to put the energy in while it's squished. You can't put the energy in when it's contracting, or the energies are going to combine into a null effect. So you're not going to add energy to the next electron. You won't be able to push the electron into another electron on another atom because you're adding the energy where it's going to get defeated. And you're not going to continue the cascade of the energy. You've interrupted it because you're at the wrong resonant frequency. So anyway, but this geometry is exactly the same. So in a radar experiment, for example, where you have two sources, it's kind of obvious, you could argue, that just due to geometry, if their two-wave theory is basically just saying, well, I have two frequencies that are the same, and I'm going to combine them at a location. Well, we know that radio waves can't do that. If you send two frequencies, the same frequency radio station, to a location, and they're a little bit out of phase, you get nothing. You can't tune in this station, you can't tune in that station. So they have to be perfectly in phase with each other, or you get nothing. So it's the same on-off pattern, and it's just jamming. So in radar, you're just jamming the signal. This is a kind in light and photons. It's the same thing. It's a kind of jamming in the sense that you've broken the frequency. And if you break the frequency, you break the cascade that happens on the surface that creates the photon, all right, that can reflect. So, so the whole point is that these are really just point sources. And their own math is really saying, there's not a wave coming out of here. There's not two. I mean, their drawings don't make any sense, right? I mean, they have a single slit pattern, and they're basically saying that somehow there's two waves that do that. That wouldn't make any sense, and it's not what they're mathematically describing. They're mathematically describing a wave coming out of here and a wave coming out of here. That's what they're doing the geometry from. They're doing the geometry from the surfaces. They're not doing the geometry from the wave centers. So obviously the idea that the photon splits in two and it comes out with two waves in the single slit is preposterous, frankly. It's just nonsense. Can't happen that way. All right, so now let's do the double slit. And this should be enough for you to get the idea, and we'll go deeper later. Alright, so the traditional story or fable or whatever that the physics is described in this wave-particle duality, the mystery of the double-slit experiment, they've left so much out that can be deduced and figured out that it's really quite disturbing that the physics of such a simple experiment has been so perverted and distorted and manipulated. So the traditional notion is that you project this thing on a flat screen. Well, the math isn't really predicting a flat screen. It's predicting an arc, okay, an equidistant arc. Okay, that's what the math is really predicting. And if you start thinking about, this idea of, oh yeah, I'm going to send infinite, I can have an infinite number of bars if I create an infinite plane. Okay, so no, there's no infinite plane. There's just locations in space, and these are what you're trying to predict, is these locations in space and what will happen at these locations. And the simple mathematics is there's a certain amount of space here, okay? There's a certain amount of distance between these 2 point sources. And the fact is there's only a certain number of possible places where like if I was to change this distance and from here to here, from here to here, from here to here, from here to here, you can understand that there's only a certain number of these lines I could draw in this place where I'd have a wavelength of difference, where there'd be a wavelength of difference in these two lines. So there's a limited number, and it's exactly how many fit in here. So you just take this distance, this A distance, and you just divide it by the frequency of the light, and you know exactly how many bars you're going to create, how many ons and how many offs. So it'll just tell you exactly how many places there can be a wavelength of difference, and you can sort of understand that by just drawing these lines to this location. So the equidistant distance, equidistant from here to here, or from here to here. And you can understand that these two lines would be 2 point sources with these. This is the difference. The difference is this number of wavelengths. Okay, so it's telling you right here what this is going to be. And the fact is because this might not be a full wavelength, this might not be a full on or a full off. But whatever this is, whether this is a half a bar, so I could draw the bar like this. So it's really, the center is 3/4. All right. You could sort of understand that that has to come out up here eventually. It's going to affect these results. Now these bars get bigger and bigger as you go out, so they get smaller and smaller as you go towards the center. I won't go into exactly the reasons for that, but that's part of because of how you're changing the angle of this circle. Okay, and you have two different starting points. So another thing they say is that we know the center has to be an on. Well, the center is inside. This is 1 millimeter traditionally, less than a millimeter of width. The only center is this, inside of the 1 millimeter. There is no center, okay, somewhere other than inside that 1 millimeter. Everything else are two lines that are actually going in the same direction. See, these two lines are going in opposite directions to create this center. So the only on is a tiny thing inside of 1 millimeter on the screen. No matter how far you put the screen, this on has to be just 1 millimeter. It has to be a tiny little on. And the real pattern is from this location here is creating a pattern, and this location here is creating a pattern. Those are the real fringes. Okay, so you're taking energy from this side and combining it with energy on this side. Again, just because of scatter. All right, so the photon pieces are scattered. The bits of the photon are scattered. You're just saying, where do I have them back in phase? Where are they out of phase? Back in phase, out of phase. So you're sending bits, you're sending energy to all the locations. All the locations are getting hit by little bits. And it's only the ones that are at the right frequency are ones you see as a photon in terms of the reflection. But yeah, so you can calculate right here. So this tells you exactly how many nodes you have. All right, and so you can understand that if I had, and it tells you their size. How many you have is also telling you how big they are, right? So if I have a standard distance and I change the number, I'm going to obviously change their size. So you can sort of understand that if I take these 2 point sources, okay, this short distance, well, that's going to say that makes 5 bars. All right, so those bars will be big bars, big bars, big bars, big bars, big bars, big bars. Now the center that's double is double because it's really these half node situation. If you start with a half node here, you're going to have a half node here, and so the two are going to overlap. So it's really just two nodes that overlap that create the double maxima in the center. I mean, I could go into more details on that, but there's only so much time and blah blah blah. So anyway, back to the real point here. Okay, so you know that this is only creating 5, this short distance. So these 2 point sources only create 5 bars. But this is a big distance. So this is going to create much smaller bars, but this is going to be more. So there's going to be 15 here. So they're going to be many more. Those are the little dots inside of the big bars, right? So that explains the X. That explains the places that are missing. The places that are missing are where the two sources, all right, of the 4 sources, 2 of them are in phase, but the other 2 are not in phase. Okay, so the locations, the only place you have light is where all 4 sources, okay, so I have 4 sources, all 4 sources are sending at the right frequency, in phase. When only 2 of the sources are in phase, Now, this is what I'm going to get. I need all 4 to be in phase to get a dot. Alright, and so you can understand why the two patterns, the envelope pattern exists, what it is, what its origin is. It's just a matter of fact that this distance creates very small bars, very small dots. This small distance creates very big areas where the photon pieces will land in phase. And when you have them both in phase, you'll get the pattern. When they're not both in phase, you don't get pattern. And it's that simple. So the whole thing is really simple. And the diagram is clearly point sources. You would not draw waves that go halfway over, right? You wouldn't draw the wave going halfway over the surface and halfway into the opening. That's the location that mathematically works. Clearly, the surfaces are the sources. The surfaces are creating all of the pattern. Okay, everything in the middle is, yeah, it goes straight through the openings, the brighter light in the middle. But the rest of the pattern, everything this way is created by photons that have to go by a surface. That's the story. Particle theory works really well. Wave theory makes very little sense. Again, having a wave that goes halfway over the surface, having a wave center on the surface makes no sense at all. Alright, I think that's enough on photons for now. I mean, you just go on and on with all the experiments and how this particle theory explains it. All you're doing is breaking photons and remaking photons. I mean, polarizing filters also explain, because in a sense they don't absorb any of the light. All they're doing is making the light not the right frequency. They're taking light that goes in, they're putting it out of phase, and then you can put it back in phase again. You can restore the light, and that's a proven fact of polarizing filters. You can have 2 filters that block all the light. You can stick a 3rd filter in, and you can get back 30% of your light. Well, you could only get it back if it was still there. It didn't get killed by the filter. It only got disrupted by the filter, and you can correct the disruption. The energy's still there. Again, the same energy is hitting all of the surface. When you see the pattern, there's the same amount of energy hitting the surface. The same amount of force is hitting the surface in all locations. It's just some locations it's in phase, and other locations it's out of phase. And that's it. Some it has the right frequency, others it has the wrong frequency. It's hitting with the wrong pattern. Alright. Well, I think that's enough for now. Alright, the subject is energy. And it's kind of a deep subject, but it's a subject that kind of shows how fragile and weak most of the foundational assumptions of physics are. You know, they've assumed things about bent space based on very limited evidence. The Yankton experiment is an example. It got, frankly, Einstein, a New York Times headline saying Einstein right. Made Einstein famous overnight. And yet the experiment hasn't been repeated, even though there's 400 times better resolution from space. And the experiment can be done without an eclipse. It's never been repeated from space. You know, sort of just indicating that maybe it's not true that light is bent twice as much by gravity, or that light is bent at all by gravity. So that's a separate subject, but it's just this story is just as bad as that story, in the sense that there's another duality. So like wave-particle duality, we have the momentum versus the mv versus 1/2 mv squared. So Newton said mv, okay, quantity of motion. That's all that mattered. They kind of measured it as they measured weight in foot-pounds, but it doesn't really matter. That's all there is. Okay, that's what a force is. Force equals mv. You know, we put a little time thing here, so basically you could say, yes, you divide how many, you want to know how much force there is per second? Well, then you put seconds here. You want to know how much minutes? You put minutes, but you don't need any of this crap. So we basically just said, you want to see that you want to see a change in something's momentum, the change will equal the force that was applied. And instead, they've converted that into the new modern 1/2 mv squared. And they say that equals energy. That equals force. All right. And it's also based on another mistake of, defining work as force times distance, when work is really force times time. It's how long you're in a force. So the gravity example, if I have a gravity well and I shoot past it, the faster I shoot past it, the less time I spend in the gravity, the less I'll get bent. The more time I spend in the gravity, the more likely it is I get pulled in. So it's clearly a time-dependent force, not a distance-dependent force. This amount of gravity is a set amount of gravity. And the only thing that's going to change how much I get bent is how fast I go through it. And that's that simple. So clearly this work equation is nonsense. And this, in my opinion, is a nonsense. And it can be proven. So the history, we'll do the history first because it's just so glaringly bad. So Newton proposed his theory a year after a guy named Leibniz suggested in his theory, okay, that the force equals mv squared. He didn't have any half in it, so the difference in the equation was a half, which is a rather substantial difference. But anyway, and it was all based on an understanding of his understanding of gravity, which is, it takes 4 times the height to double the velocity in gravity, with the assumption that somehow the 4 times the height is the important part, not the doubled velocity. And so it's 4 times the energy, because each unit of gravity was equal to the same amount of work, even though Galileo already proved that it's 3 to 1, 1, 3, 5, 7. The amount of gravity you're going to experience as you go faster and faster is going to be less and less, and it's going to have less effect. And so it's really only 2 units of gravity. Even though you move 4 units of distance, it's only 2 units of gravity, 2 seconds of gravity. So anyway, so Leibniz suggested this, and so people thought about it, and they pointed out how, well, now there's free energy, because, a lever creates free energy. They made these arguments to say, you can make a lever, and you can put your 5-ton train going 5 miles an hour on one side, and have a 10-ton train going 10 miles an hour on the other side, 5-ton, 10-ton, 5. And one of them will have twice as much energy as the other, even though on a lever they'll create each other. That is, the half-mass object going twice as fast can create the full-mass object going half as fast. So levers become free energy devices. So every time you use a lever to convert the energy, you're not really converting energy, you're really creating energy. It also makes a mess out of things like guns. The bullet has 2,000 joules. The gun's recoil has 2 joules. That violates Newton's third law. That's not an equal and opposite reaction. So lots of these kind of arguments were made, blah, 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 and Newton won, basically, the argument. Okay, Leibniz died. Nobody. And let's understand, Leibniz, when he proposed mv squared as the true measure of energy, he stated it in this context of stating that he thought Newton and Descartes' physics was too atheist. And so, not adding much credibility. So anyway, Leibniz died a nobody. Newton lived a little longer, and the solid consensus was that Newton was right. Momentum is what runs the universe. That's how Newton did his calculations. It's how he figured out when Halley's Comet was showing up. He got right answers with momentum. And then around 1720 to 30, a French woman who was tutored by a Leibnizian, somebody who was of the old school, the Leibniz school, believing in things called solitons and monads. Not electrons and protons, no, solitons in the spiritual sense, like they had a soul. I don't know exactly, a monad was like a half a soul. But anyway, just, kind of rubbish physics. So that's who tutored her, and so she became a devotee of the Leibnizian idea of mv squared, and found another guy, some Norwegian or something anyway, who was doing clay experiments, dropping balls into clay and observing that he could make the twice as he could make the one going twice as fast penetrate the clay 4 times as much. Now, no one proved clay to be a very good way of measuring something's energy, so there was no real evidence that it's a good unbiased ruler. And somebody could make the argument that it has a bias for velocity. The faster you go, the deeper you'll go into the clay. I can mix cornstarch with water and create a fluid substance that if I drop things into it, it'll do exactly the opposite. Fast things will be stopped from penetrating, and slow things will be allowed to penetrate. So, not a very good experiment. The other experiment was sand, where she dropped things into sand, and the sand went far away when the faster thing hit than it went when the heavier thing hit. Well, that's kind of obvious. Faster things have higher velocity. They can create higher pressure and force things to move faster and further. It doesn't mean total energy. Wattage-wise, it's the same. So you can make an analogy to voltage and say, look, voltage is voltage times amps equals watts. A watt is the same as a joule, okay, a unit of energy. You don't have volts squared, okay, times 1/2 an amp. It wouldn't be rational, it wouldn't be reasonable, and it's not reasonable in this context either. So anyway, she did these experiments. She fooled everyone, essentially, apparently. With these simplistic experiments, because there really wasn't any kind of real arena for debate. It's not like everybody showed up in some debate theater and made all their best arguments and everybody heard the arguments and everybody did all that stuff. It was really just a popularity, how socially connected you were. Lots of things decided whether your theory became the dominant theory or not. There wasn't any real rigorous testing. And so they fell for it. Then in the 1800s, I guess they started to realize these numbers, the amounts, the joule number, the foot-pound number, was way off. And they also associated Joule, the guy they named the Joule after, had done some experiments converting motion into heat to measure how much absolute energy something has. And they're very good experiments, perfectly rational, but they did them in the context of mv squared because they were using gravity, again, as the source of the amount of energy. So they assumed the source energy, and the product is all quite circular. And that's when they came up with the work equation of force times distance, because they were measuring how far something falls in gravity and assuming that it has twice as much energy as it actually has. So anyway... So that's all they really have. So they have no real experiment. Now they'll say right on their Wikipedia page that it takes 4 times as much fuel to go 60 miles an hour as it takes to go 30. Never proven, never demonstrated, never shown. No experimental evidence anywhere ever showing that to be actually true. Okay, you could have surmised that a wrecking ball swinging, you could swing a half as light wrecking ball twice as fast as a twice as heavy wrecking ball. That would be your assumption. It's not going to go 0.4 faster. No, it's going to go twice as fast. And that the fact is that the smaller wrecking ball would knock down more buildings, twice as many. Same argument would be made for bowling balls. I mean, if you can throw a 16-pound ball 8 miles an hour, you could figure you could throw an 8-pound ball 16 miles an hour, and you'd have twice the energy. So why aren't bowlers using 8-pound balls if they can get twice as much energy out of it? So lots of reasons to doubt this. The spaceship analogy is, perfectly viable. NASA overtly says it uses Newtonian mechanics. Now, it doesn't say that means we're not using kinetic energy, but that's what it means. Because NASA knows that if it shoots the bullet out one side of the ship, ties the gun to the ship and shoots a bullet, and gets 2,000 joules into space. It makes 2,000 real units of energy into space. That it's not going to turn any more than if it ties the bullet. That is, it stops the bullet and allows the gun to fly out. The gun only has 2 joules. NASA knows that it's going to move exactly the same. The bullet's going to cause just as much change in the direction of the spaceship, just as much momentum transfer. So their joules aren't real. They can never collect them. They're not real entities. All right, so I'll go over a couple of experiments, and I'll just make this lever argument. There's other arguments, but the lever argument's decisive in kind of pointing out that it just can't possibly be true. All right, so I decided to do another example first, just because I just thought of it. It seems pretty decisive. In terms of illustrating that you can't do this friction thing. So the traditional way of measuring energy is to take some rolling device and have it roll across a surface, and then you measure how far it goes, And you say that has something to do with revealing its energy. So if I do that, I create two cars, one car going twice as much as the other car, so the velocities are doubled. The fact is the one velocity car will only go that far, and the two velocity car will go 3 times further. So it'll be the same ratio as gravity. And the simple truth is it's doing exactly what gravity does. The twice as massive car will only reach half its velocity when it's 3/4 of the way down the track. So it's only going to be half here. Okay, half its speed. It's going to take that long for, that much distance before it reaches half its velocity. Because it's doing exactly what happens in gravity. You're going through the friction faster. So the amount of distance you travel here is an amount of friction. Well, the amount of friction you experience here is going to be the same amount of friction. So it's really only 2 units of friction. So one experiences 1 unit of friction, one experiences 2 units of friction, to double the velocity, half the mass. You can figure it out. So it's really just about the fact that friction is not a good ruler. The amount of energy you're using per foot, it changes. How much energy goes into the ground changes as you increase your velocity over the ground. So the slower you go, the more weight from gravity, but more importantly, the more weight, the more of your velocity goes into the ground. So the more of this part ends up being pushed into the ground by the part going down. So you lose more energy the slower you go. And the faster you go, the less energy you give to the ground. And you can sort of know this from experience. So friction, you have to get rid of friction, because friction isn't a good ruler. This distance thing is ruined because friction is gravity dependent, at least this kind of friction. So you can have a different kind of friction, air friction, and you can say, well, you can negate it because it doesn't have a bias in a direction or any of that other stuff, so it's not going to be that big a deal. So you just launch 2 objects off a cliff, and what you'll find is that, what you can know mathematically can't be changed is the one with twice the velocity will end up going twice as far in the same amount of time. They're going to fall in the same exact time. They're going to land exactly at the same time. The one velocity object and the 2 velocity object. They hit the ground exactly at the same time. So they have the same amount of time to travel through space. Okay, and obviously the one going twice as fast is going to travel twice as far. No doubt about it. So all you need is to be able to launch the ones at these 2 different velocities. Well, you can do that by just setting up a ramp, okay, and taking advantage of the gravity, and it's 4 times to double the velocity. So you want 2x the velocity. So in one experiment you go up just 1 unit of distance. The other experiment you go up 4 units of distance. And when you do that, what you'll find is that you'll double the velocity, and you'll get these outcomes, and there'll be no evidence of any distance that's going to be 4 times the distance. There won't be any 4 times the distance in this outcome, demonstrating it's only really 2 times the energy. So this experiment will prove the case kind of decisively. Game over and such. And even though it's angular momentum, it's still, there's velocities in the object as they fly into space, and the angular momentum will be an equal proportion of their directional velocity, so it won't change much. There was some other point I wanted to make, so I'll pause for a second to make it while I have the opportunity. So the other thing that's important to recognize, that if I measured them here by having them crash into a common scale, a scale that you use to, measure the weight of something, and I just, turn the scale towards them and allow them to hit the scale, well, the twice as much velocity is going to equal, even though it's 4 times the distance it rolled, it's only going to be twice the weight. Okay, so that's all it's going to be, 2 weight. So it's going to take, everything's going to be everything's going to be the same. The time is being controlled in this experiment. In the other experiment, twice the velocity will take twice the time to do the same amount of distance. So the thing that goes 4 times further will go 4 times further in just twice the amount of time. All right, so you have twice the unit, 2 units of time, 2 units of weight. All right, so you have good reasons to believe, yes, it's 2 units of energy. Okay, and So moving on to the lever. Alright, as the graphic below says, force equals energy equals momentum equals work equals weight equals heat. It's all the same stuff. It's just the movement of electrons and protons, and as a result, the movement of atoms and the movement of compounds and the movement of objects. It's all based on just velocity, mass and velocity, and that's all there is. And alright, so a lever points out how, it just makes the obvious point that if I have something at twice the distance at one side and half the distance to the other side, you can understand this oscillates at twice the distance. Not 4 times the distance, twice the distance that this moves. So whatever movement you have at the one notch, you have twice the movement at the other. Okay, so let's make them proportional. It's pretty close. Alright, and so, and it's a rigid lever, so there's no way to change how it moves in some respects. So if I put a 2 mass here, and I put a 1 mass here, okay, I guess I should have, well, it doesn't really matter, you get the idea. A 1 mass here, alright. Technically, they weigh the same. Okay, the lever will say they weigh the same. It's a balance now. It's going to say the 2 mass at this position is the same weight as the 1 mass at this position. Because the fact is, when it oscillates, this will be oscillating at twice the velocity. So it'll have twice the velocity of this. And so you can sort of understand that that's what's really happening in gravity. Right now, you're oscillating in gravity. And if I change the rate at which you oscillate in the gravity, that is, I increase the velocity of that oscillation, I'm going to increase your weight. I'm going to increase how much pressure you put on the Earth by increasing how much you're pushing into the Earth per millisecond, right? I mean, or billionth of a second, or trillionth of a second. You're being tested right now. In gravity right now, you're pushing into the Earth, and the Earth is pushing back, and you can feel the Earth pushing back. You can't feel the gravity because the gravity is moving all of your little bits equally. It's not pushing part of you, it's not moving your eyeball or this part or that part, so you don't feel any differential. Because this gravity is working on your electrons and protons, and so the protons and electrons next to each other aren't going to get different amounts of pressure. They're all going to get the same amount of pressure evenly. But clearly the pressure coming from the Earth isn't even. Okay, most of it's happening in certain locations whether you're sitting or standing, and you're going to feel it in different parts of your body, that differential. So you don't feel gravity when you're free falling, but the fact is it's pushing you pretty aggressively. And you only feel the counterforce because it doesn't push you in the same way as gravity did. It doesn't push your electrons and protons. It pushes your surface, and it has to go through all the atoms. The energy has to migrate through your body, and it migrates through your skeleton faster than it moves through your flesh and through your blood, and all these different things move at much different rates. And that's why you feel the impact of the counterforce. But the force of gravity is a real force. The counterforce is a real force. Okay, and all that's really happening is electrons and protons are being moved. Alright, so anyway, the lever can't tell. So whatever I put over here, whether I put a 2 mass here or I put a 1 mass here, the fact is the lever will move exactly the same. I'll feel exactly the same on this side. So if I was to move this side of the lever, alright, without the mass here, and I was to switch a 2 mass here for a 1 mass here, I wouldn't be able to tell the difference because they weigh exactly the same, and they would move exactly the same. In terms of the 2 mass will move half the distance, the 1 mass will move twice the distance, no matter how much pressure I apply. So essentially it's always going to feel the same. This side of the lever can't tell what's over here. If I was to take all our best physics and we were to examine this side of the lever and try to tell when there's a 1 mass here or a 2 mass here, there's no way to tell because only the energy going through here is just giving you a weight. That's all that's coming through the lever is an amount of pressure. And the fact that one of them is moving twice as much as the other, you'll never be able to know. You'll never know the difference between the two. So the lever can't lie. All right, and the truth is that if I was to oscillate this lever, I've done it with the lever that was 4-to-1 actually, so I was creating 4 times more energy. But the fact is, physics says this object is perfectly oscillating. I throw energy in and it oscillates perfectly, 50, 60 oscillations. All right, And through all those oscillations, you know the only way the lever works is it stores the energy in gravity and gets the energy back, the same amount of energy. So there's no way to have more energy on one side, but physics says this has twice the energy. All right, 1/2 mv squared says this smaller object moving more velocity has twice the energy of this object here. Now there's just no way to logically make that make sense. And if I actually did the experiment, okay, and you can think of this as the 5-ton train going 10 miles an hour, and you can think of this as the 10-ton train going 5 miles an hour. Physics says this train has twice as much energy. Now, we've never seen that experiment done either. We never saw the tug of war between the 10-ton train and the 5-ton train, or the 5-ounce train and the 10-ounce train. We've never seen that contest to prove that somehow the 510 somehow has twice the energy and decisively wins the tug of war. We've never seen that. And NASA knows it isn't true because it knows all the time when it navigates space that it can only use momentum. It can't use this fake energy. Alright, so clearly once it's oscillating, I could stop the oscillation at its peak velocity, which always is the straight part. And these objects, I could leave them free to fly off the lever. And the fact is this will fly off at twice the velocity. And the fact is this will fly off at half that velocity. Okay? And the fact is that how can the lever possibly create twice as much energy on one side? I put 100 joules of energy in this side, and I get 200 joules of energy out this side, or 400, or 800. How could that possibly be true, that I could make free energy by just dumping heavy things on one side of the lever and collecting light things on the other side of the lever and just keep making free energy? So obviously free energy isn't this easy. We all have one. So clearly there is no such thing as this 200 joules. It doesn't exist in reality. It's 100 and 100. It's 50-50. It's whatever number you want to say, but regardless, whatever the number is, it's the same amount of energy. And it's a decisive argument, and it really should just be fessed up that physics was fooled. Benjamin Franklin accidentally, wrongly assigned plus and minus, and they never fixed it. Even though now they have silly things, that because of Maxwell's equations, they end up having amperage going through a wire one way, and they have the voltage going through the wire in the other way. Totally nonsensical. So clearly physics is capable of making mistakes and capable of not, and just adapting to them rather than admitting them. And kinetic energy was always a fable. And the fact that they had to change it and put a 1/2 in front of it should be a huge giveaway that, yeah, it was real fallible, phony physics. They proved, decisively proved for 100 years mv squared. From 1720 to 1840, they proved mv squared, and then they stuck a 1/2 in front of it. Come on. It's bullshit, frankly. It's just a nonsense. Way past time to let this one go. All right. That should be enough.